The Thevenin equivalent voltage VTH in bold round off to 2 decimal place of the network shown below is. So here it is a question. It is a easy one. Let's solve this question. If we see carefully this portion, then we find that whatever voltage is here appear here directly. What is the reason behind it? Because there is no current flow here due to open circuited. Apart from this, if we see carefully in this section, we find that 4 volt is directly connected to 3 ohm. So 4 volt is developed here directly. This is totally negative. Let's say this point is A, node A. Applying KCL at node A. So VTH minus 4 divide by 2, incoming current take negative, equal to 0. VTH minus 4 divide by 2 equal to 5. VTH minus 4 equal to 10, and we get VTH equal to 14 volt. This is the answer. This is the one way to solve this question. And another method to solve this question is by source transformation. We can convert this 4 volt source into current source by source transformation, like this. Four volt, 3 ohm, convert into current source. 4 by 3 ampere current flowing in this section. So 3 ohm resistor में से 4 by 3 ampere करंट फ्लो करेगी इसमें. Okay, voltage across 3 ohm is V equal to IR. V equal to 3 into 4 by 3, we get 4 volt. So we can convert this 4 volt into current source in series with 3 ohm. This is called source transformation. So now we will draw this circuit. Polarity as it is, 4 volt, 3 ohm, current 4 by 3 ampere. Plus minus VTH. Now apply KVL in this loop. We start from negative. VTH, no current flowing between 3 ohm, voltage across this 0, plus minus 2, current flowing 2 is 5 ampere, means 10 volt, plus 4 volt equal to 0. We get VTH is equal to 14 volt. This is the same answer. So we can find currents through ammeter A2 and A3 in the figure are one at an angle 10 degree and one at an angle 70 degree respectively. The reading of ammeter A1 is in ampere. Next question is like this, as the figure shows that I1 and I2, I3 flowing from emitter A1, A2, A3. The values of I2 and I3s are 1 at an angle 0 degree, 1 at an angle 70 degree. We have to determine the current I1. How much current flowing from emitter A1? A round off up to 3 decimal places. So almost people answered this question 1 plus 1 equal to 2. Is it right? No, it is absolutely wrong. So to solve this question we use a phasor. Suppose I2 take reference 1 at an angle, sorry, it's a 10 degree, and I3 somewhat here 1 at an angle 70 degree. So 70 minus 10 go to 60 degree. The phase difference between them 60 degree. So this is a parallelogram. We can find the magnitude of I from here. So we know that the formula of parallelogram I equal to under root I1 square plus I2 plus I3 का square plus 2 I2 I3 cos theta, where theta equal to 60 degree. Substitute the value here. The magnitude of I2 and I3 1 square 2 into 1 into 1 into cos 60 means cos 60. 1 plus 1 plus 2 into cos 61 by 2. So 1 plus 1 plus 1 we get under root 3. So what is the value of under root 3? 1.732 ampere flowing from A1 emitter. So it's the answer. A backtop DC power supply acts as an ideal 4 ampere current source as long as its terminal voltage is below 10 volt. Beyond this point, it begins to behave as an ideal 10 volt voltage source for all load currents going down to 0 ampere. When connected to an ideal resistor, find the load resistance value at which maximum power is transferred and the corresponding load voltage and current. So indirectly say that it's a solar panel. So we have characteristics like this as per the conditions given. Below 10 volt it acts as a current source, value of 4 ampere, and beyond this point it begins to have an ideal 10 volt voltage source for all load currents going down to 0 ampere. So if we see carefully here, it is the IV characteristics of solar panel, and the one important thing to notice here is that when connected to an ideal rheostat, so first of all we have to find the value of rheostat. V equal to IR, V is equal to 10, I is equal to 4 R. So R equal to 10 by 4, 2 to the 2, 2 5 the 10 means 2.5 ohm. resistance 2.5 ohm at which maximum power is transfer. So if you notice that, then you can find here current is 4 ampere but voltage is somewhat lesser from 10 volt. Here current is 4 ampere, voltage is lesser. Here current is 4 ampere, current is different value. Sorry, voltage is different value. Here current is 4 ampere, voltage is different value. So throughout this span, voltage changes, but the current is constant throughout this span. So we can say this is the only point where current and voltage maximum. So I equal to 4 ampere and V equal to 10 volt. At these value, power transfer is maximum. So it is the answer of this question. A resistor and a capacitor are connected in series to a 10 volt DC supply through a switch. The switch is closed at time t is equal to 0 and the capacitor voltage found to cross 0 volt at t is equal to 0.4 tau, where tau is the circuit time constant. The absolute value of the percentage change required in the initial capacitor voltage if the zero crossing has to happen at t is equal to 0.2 tau. Resistor R is connected in series with 10 volt supply through switch S. Switch is closed at t equal to 0. Battery having 10 volt. So the interesting point here is to be noted that here the capacitor voltage is found to cross 0 volt, means 0 volt, cross 0 volt at t is equal to 0.4 tau, like this, 0.4 tau. Tau is the time constant of this circuit. Tau is equal to RC. We know that time constant of RC circuit, tau equal to RC. What the question says that absolute value of percentage change required in the initial capacitor voltage if the zero crossing has to happen as t is equal to 0.2 tau, means 0.2 tau is earliest from 0.4 tau, means somewhere here like this. Zero 0.2 tau. So we have to determine this change. It is not in percentage, it is the absolute value of del V. So first of all, we know the equation of RC circuit, Vt equal to V infinite plus V initial minus V infinite e to the power minus ty tau. So Vt 0 volt is crossing, so Vt equal to 0, V infinite 10 volt is reached, the maximum value. We don't know the initial voltage, let's say V naught dash minus 10, V infinite t is equal to 0.t tau. At 0.t tau 0 volt crossing is reached, t is equal to 0.4 tau, tau cancel out, we get this equation. So let's rearrange it. multiply inside rearrange this whole term goes in dividation. Now when this term goes to upwards, the power will change. So here we have to use calculator. There is a difficult one question. To solve this question by calculator, we get approximately 4.92 something. Now when 0. At 0.3 tau, zero crossing is happen, so total equation remains unchanged. Only 0.2 tau is substitute here. Tau cancel out. 0.2 tau means the remaining equation is same, only 0.2 tau is placed here and here. Minus 10 plus 10 e to the power minus 0.2 e to the power plus 0.2, and after that by solving this equation we get 2.21. Now let's say it's v naught double dash. Now we get the voltage, initial voltage of capacitor v naught dash or v naught double dash at 0.4 tau, at 0.4 tau, at 0.2 tau. So we have to determine change difference, means 4.92 minus 2.21. This is change. What in question says the absolute percentage change with respect to initial voltage. Initial voltage meant when 0. At 0.24 tau, at 0.4 tau zero crossing has to happen, means with respect to initial voltage 4.92. 4.92 into 100 we get something 5.5081 is your answer. If you like this video, please like, subscribe and share. Thanks for this watching.